You'll hear this. You hear me hitting the screen when I'm doing this. So now all of a sudden my microphone doesn't work. Anyway, so how many times is 12 going to 3? These are important questions, by the way. No, wrong. No times. So you have to go to 34. How many times is 12 going to 34? Now, and then you put the 2 up there. You have to, for the position, you're in the hundreds. What is this lesson? This is so stupid. All right, 2 times 12 is 24. And then you subtract. This should definitely be smaller than 12. Otherwise, you didn't go far enough in the first thing. Then what do you do next? Bring down the 7. Remember all the, oh, by the way, I'm sorry. And then you subtract, right? I'm going to tell you right now, you're going to see the next thing, which I warned you is probably going to be the hardest thing you're going to have to do this year. And it might be, it's because people panicked. But actually, these are the steps. These are the steps. Grade school. All right, how many times is 12 going to 107 approximately? I think it's 8 because that's 96. Then 8 times 12 is 96. Then what do you do, class? Say it. Subtract. And then you get 11. And then you bring down a 3. Run out of room here a little bit. How many times 12 going to 113 then? I think it is 9. One bump more up of that's 90 and then 108, right? And then I'm just out of room here. Isn't that 108? What's this called? What's 5 called? The remainder. Now, we did that. Someone said, well, we only did decimals when we were in grade school. So we put a plus 0, brought the 0 down, and we kept going, and that's where the decimal was. You guys, no way. You learned this first. This is when we learned what a mixed fraction was. 289 and remainder over divisor as a tack on, and that's what a mixed fraction is. Then you can turn it into an improper fraction by multiplying 12 times 289 plus 5. These are all grade school things. Notice what I said, 289 and 5/12. That's how you read it. You know what the word and actually means in math? Plus. So it wouldn't be wrong if you wrote 289 plus this little leftover 5/12. Remember, I said that for polynomial division. And now we're getting into it. We're going to actually divide these two right now. What? This isn't the same as grade school. Who goes on the inside, everybody? Who goes on the inside? That's enough. 28, the one with the 28 in it. If you crinkle that bottle one more time, I'm going to take it and smash it. Sorry, the crinkling water bottles. Used to be no drinks allowed. Now we got $5 cafe Lockport lattes over there. People coming, can I go get my coffee and miss 10 minutes of class? And then people crinkling water bottles left and right. It's like it's the Sahara Desert. Oh God, I couldn't get through that lesson. I had to suck down some water real quick. Oh, it's just that's what we live in now. Teaching in America, right? Another lesson. Oh God. Another drink. Anyway, now here's how you do this. Remember this before? Remember we said, does 12 go into 3? Yes or no? No, but get a drink of water. All right. And then does 12 go into 34? Yes, right? Okay, so we focused on 12 and just the 34, right? Right. Okay, so this is now, okay, fine. A grade schooler couldn't do this. But you can. All you need to focus on is this, and then ask the grade school question. What times this equals that? And there is an answer for it. Fumble, what is it? 7 what? Now, I was just yelling at people in tutoring today that this is what you should do. You should put this above the squared position in the spirit of grade school where you put the 2 over the 4, but it's not really the same thing. But really what it is to keep yourself organized. So what this tells you is you may only have 2 more steps as well. That's what it tells you. Just like up here, this tells you that, okay, I put the 2 here. I got to go all the way to the end here. I have 2 more steps there. That's why you should do it. Okay, but then this is algebra. How do I take 7x squared times 4x minus 3? What's the word I'm using here? I'm going to use next. What would that be called? distribute, but we have to look at it in a weird way like that. Okay, again, this drives me nuts when the student says this is hard. And I was being sarcastic about this is the hardest thing you're going to deal with. But for some reason, students can't put all of these things together that they know how to do into this question. I don't know why. They can't organize or something. All right, so we can 7 times 4, 28, x cubed. And we can, what's 7 times -3? -21x squared. And we do want to line up like terms. Watch, sometimes this will skip. I hope I picked the right examples to see that happen. And then in grade school, what did we do next? What did we do next? We subtracted. This is the part that the students can't handle, the ones that are bad algebraically, to be honest. When I subtract the binomial, what do you have to do with that minus sign? Distribute it. So this becomes negative, that becomes positive, and now I can add those together. And what better darn well happen, and I'm staying green here, is those first set of terms cancel, and now I have the next set of powers here. This is 16x squared. So I'm a liar. Actually, the long division is not difficult. It just requires some care. Everything you have in your pocket as far as understanding algebra is there. You just got to be structured and remember your grade school division rules. Okay, and then guess what? I'm going to highlight this in blue. Oh no, what do yellow and blue make? Green. So I guess I could do this differently. Let's do it differently. Let's underline it in green. Now, what's this? What times 4x equals 16x squared? Were you listening? No, you're rubbernecking. Okay. What times 4x equals 16x squared? 4x. And you put it here, and it's a polynomial, so we need a plus there. So this is how it's different than grade school now. You don't have the next position in the number. They're polynomials as answers. So that's the algebra 2 of this. What's algebra 2? That's what 99% of the rest of the state of Illinois teaches. We have math 2. All right, and then multiply. So this is 16x squared. I gotta hide this. I really hope this is taping. I started. I hope I have sound. If not, it'll just be a silent movie, and I'm just like this. And then, what was he talking about when he was screaming and then going like this? All right, anyway. What do I do next? I pause for effect. Subtract, which means what? Distribute. I guess blue and green don't really stick out like, then look at that. That becomes 20x. So then that's your next stage. And then this is why you put, how many more steps do you think there are? Okay, there's a number. What number is the number of steps that are left? 1. Because I see that. You see that blank right there? All right, and then bring down the 16. Notice I didn't bring down the 16 here because I knew I didn't need it for that second step. I was only gonna have 2 terms to subtract. Okay, and then what times 4x equals 20x? What's the answer to that? 5. And then what do I do with that 5? Distribute it. What do I do after that? Subtract. So this is minus 15, but then this is the part that people cannot remember. I don't know why. Subtract, which for a binomial means distribution. All right, that becomes -1. And then what do I do about that? I tack it on as a remainder, but then remember what I said up there? 289, what was the word I said? And what does and mean? Plus. You have to tack it on as a plus remainder over divisor, which is 4x minus 3. And then the colors should denote each step that I did. Do you need the distribution lines? No, this is for teaching purposes. All right? So don't tell me this is hard. I'm not going to listen. What you're admitting is you can't distribute and you can't subtract the binomial by distributing a minus sign, because that's all that's happening here. Then there's one more thing. You just got to know how do I pick these numbers? in grade school. It's actually easier. I'm going to say that this is harder than this, picking the numbers. Oh, come on. Oh, this is embarrassing. This is so easy. By the way, did anyone notice anything about that first thing? Something missing? Anyone? Something missing, all right. Anyone? What's missing in that term? What term's missing? There's a missing term. Which one is it? So what do you think I'm going to do about it? Oh, I'm going to do something there. Why would I do that? For space. And then for tomorrow's new thing, you're going to need to do that. So it's a good habit. And actually, this could be tomorrow's question, but I'm not going to get into that. We're going to do something tomorrow called synthetic division that you're absolutely going to love. But it can only be used in very specific scenarios. So we do need to know how to do long division. Okay, now keep this red. What times x equals x cubed? What's the answer to that? Well, here's a nice thing. So now that I have that, I have a spot, so I have a position there. But also I need the position down there because it is going to create that term. All right, and this allows you to organize your like terms. And then I'll keep doing the distribution lines. This is x cubed. This is minus 3x squared. And then you're going to forget this. What do you do next? What do you do next? Subtract. This is the number one mistake, and I have no sympathy for you. None. Because it's right here. Look. You multiply, then subtract. Multiply, then subtract. You multiply, then subtract. Grade school. Okay, that's what the grade schoolers do. I can't even insult Lexi Samuelis by saying this is what she's doing. She's way beyond this. All right? In 8th grade. All right. Anyway, that's why this needs to be subtracted, and then you'll get the proper 3x squared. I think that's a good choice of changing colors each line. Oops, sorry. I lost a 1 there. And then there we go again. What times x equals 3x squared is all you have to focus on. The answer. 3, 2, 1, go. 3x. And then I put it over the 3x or the x position so I know how many spaces I have left. It's not mandatory you do this. It's just silly if you don't. It really is. I think it's silly, and that's what I had to yell at the people in tutoring that already had this in the morning. Just telling you should probably do this. It'll make your life better. All right, and then subtract, which means distribute. All right, good. I'll do purple, then blue. All right, and then that cancels, which is the whole objective, and then this becomes negative 4x. And then plus 16. And then what times x equals negative 4x? What's the answer? Negative 4. So don't put 4 and get opposites yet. You have to get it spot on, then subtract. Just like in grade school up here. If anyone asks me why, I'm just going to go because of grade school's division algorithm. You multiply by 2 first, got 24, then you subtract it. You didn't put negative 2 up there. You didn't even know what a negative number was back in those days, though. All right, and then negative 4x plus 12. But then what do? Subtract. Oh, this is the thing that gets you, and I'm going to get you. I'm going to get the red pen of justice out and mark you wrong when you don't distribute a negative. All right, 4 over x minus 3. You're gone. Okay, and then that's called fractional form. Did you notice that in the directions? Tomorrow there's another form I really, really, really don't like. It's called polynomial form, and we'll talk about that tomorrow. Everything's fractional form today. How many more do I have for examples? 2. You know why, though? You want to get nuts? Son of a nutcracker. Oh, okay, I do. Okay. Oh, yeah. Yeah, we're going to get nuts here. Okay, so, and I'll tell you when you know you're done. Okay, so I've been real nice, too, that these are in descending order. You notice anything missing? X to the 4th. Okay, so what do I put there? 0x to the 4th minus 5x to the 3rd. Oh, this is lengthy. Minus 29x. Oh, this is the worst. Plus, oh, my poor me, 15x. Plus, oh, God, I'm not doing this. I'm not doing this homework tonight. Minus 3x minus 2. Did I talk about my pre-calc students today? I had a review quizzes, review for the final. Over half of them need a good grade to maybe get to the next level of their grades. They're all like right on a border. Take a guess what the class average was first hour on a review final exam quizzes.
77.
You're all wrong and you're all too high. 49. Yep, and that's what I have to deal with. Anyway, 49%. Anyway, so here we go. What times this is that? So listen, you see why I do this? Okay, it's not great though. That means how many steps do I have after this? I have to get to x squared, x and constant possibly. So I might have 3 more multiplications after this. It's not hard. This one is just obnoxious and I knew we had the time for it. So x cubed times that is x to the 5th. And then we do have an x to the 4th. Okay, I'm glad I put that spot there because now I have a space for an x to the 4th term. This is why you want to do this. And if you don't, well, good luck. You're going to cause your own problems and probably make a mistake. All right, and then subtract, and then subtract. Then it did get a lot better. You know what second hour got for a class average?
58.
51. Then it got really, really a lot better. You know what third hour got? 53. Okay. All right, so 3x to the 4th minus 3. These are all true, by the way. Review for the final. Okay, so that minus turns into a plus. That's why it's positive 3x to the 4th. And then these are easy questions. It does take some time, though. Okay, what times x squared equals 3x to the 4th? What's the answer? These are all easy questions. Nobody can be sitting there saying this is difficult. Because all I'm doing is making those decisions, but also I'm just distributing and then distributing a minus sign in the correct order because of the division algorithm from grade school. 3x to the 4th. This always ends up being exactly the same. Then we throw a negative seconds. Then this becomes negative 3x to the 3rd. Wrong. What is that? Sorry, my bad, dogs. What is that? 9, negative 9. I made it. See, you make one mistake, the whole algorithm is destroyed. So do discount, double check yourself. Minus 3x squared, and then I think purple is better. Subtract distributes. Okay, that's how you subtract a trinomial completely. You have to distribute the minus sign. So this is why the use of colors is very nice. All right, and then this becomes 6x cubed, and then minus 23x squared, and then plus 15x. Notice I'm not bringing down the 7 because I know I'm going to have 3 terms, right? When I distribute all 3, you don't need the 7 yet. You need it last. You can bring down the 7, go crazy, but it's just a waste. Okay, what times x squared equals 6x cubed? These are easy questions. They really are. This is not a difficult process. 6x cubed. We'll do one more. I don't think it's as bad as this one. This is the monster of them all. Minus 8, and we're almost done. And then your notes are now after this, it's your homework. I'm not going to bother you. I'll let you do what you want to do. All right, and then green, or no, we'll go blue now. Subtract. Okay, that's the purpose of the color, so you can see that action secondhand. All right, that is negative 5, right? And I know what you're saying, like, practice not using your calculator. If you're off by 1, then it really does screw up the rest of it. So just be careful on your adding. And then what's the last number? What times x squared equals negative 5x squared? What's the answer? Negative 5 goes here, and then I got to choose a last color. I guess we'll do, I'm avoiding the black there, so we'll do the black. Negative 5x squared, that'll be my remainder. Plus 15x plus 10. I was supposed to write that in blue. Darn it. I'll do the blue. Subtract. subtract, and then I'll write the answer in black there. So this becomes 27 minus 15, 12x, and then this is minus 3. Why is that the remainder? Because it is one less degree of the divisor, which is what that is called. So that is the remainder. And this is really going to leak into that next question. So I'll write this, then I'll put this question down. This is a little bit smaller. Plus, you know, if I have to do it, let me see if there's anything special about it. But this is what you got to do for the remainder. It's the remainder divided by the divisor. This is what you have to do in polynomial world when you write your final answer. So we did that whole process, and then you write the remainder divided by the divisor. The remainder is always one less in degree than the divisor. Previous ones you were dividing by a binomial, so it was fine. There really isn't anything special with this one. I don't really know if I have to do number 5. I didn't do anything. But be careful if there's a missing. You know what? Let's change it. I don't care what the answer. Let's do this. Here, let's do this. Let's say we're dividing by x squared plus 3, just to watch what happens. So do that. I just wanted something different here. You don't really need a missing position there, but you'll see what happens when you're multiplying. It's just going to skip terms in the middle. Because this happens sometimes. I have no missing things here. So I'm going to go ahead and put 3x to the 4th minus 17x cubed plus 6x squared minus, oh, look at that, minus 15x. That stops at 15x. That's also a little different. Okay, but I'll be happy to do that. I'll say x squared plus 3. I just wanted something different here. You don't have to account for missing terms here. Account for missing terms here because you want your positions separated. As a matter of fact, with that being said, put plus 0 here because we are missing the constant. And you will probably have a constant position. So just to know your positions of how far this is going to go. Does it feel cooler in here now? I feel like we're finally getting some air conditioning instead of the humid stink coming out of that thing usually. All right, what times x squared equals 3x to the 4th? What's the answer to that? And that's easy. 3x squared. 3x squared times that is 3x to the 4th. This is not a big deal. You could survive with this. This is 9x squared. So we skip the x cubed term because there isn't an x cubed in that spot there. I don't know what else to call that. Turn to green, subtract, but then don't ignore this. This is nothing to be subtracted from 17x cubed. So it is negative 17x cubed. I should have said negative. And then 3x squared. So it does create that x cubed position still. Don't ignore that. That's got to be subtracted by 0. Negative 17 minus 0, x cubed. I am going to need this spot, but I won't need the 0. Okay, what times this? X squared equals negative 17, x cubed. It's negative 17x. I don't think I have to ask that anymore. So this becomes negative 17x cubed, but then we skip. This is 30, 7, 14, 21, 51 negative. But we subtract. Don't forget the negative 3x squared. And then 51, 41, 36. And then you are going to have something, you know, messing around with 0 there on my last term. So I guess that was a good change. So it made that different. I'll do the same thing for 7th hour. And then the last thing is, come on, it's negative 3. Negative 3 times x squared is spot on, negative 3x squared. Negative 3 times negative 3 is negative 9. But then subtract. That's a 3. And then the remainder is 9. Wrong! 30. I did it. I forgot that 36 plus 9. Oh, see that? See how there's so many things to miss, though? That's what happens with the not so careful algebra students. That's the only ones that struggle on this, those that are not careful algebraically. So it is a true test of your algebra skills. Then why do I know this is a good remainder? the numerator's degree is bigger than the denominator. Wrong. I said that in a reverse way. The numerator's degree is smaller than the denominator. It can't go any further. I can't multiply this by this unless it's some sort of, something you don't know about. Just shut up at this point. Everyone good? That's over. That's all she wrote.